So we'll start the recording. We continue yesterday's class about the parameter. So the lecture part, the note part doesn't have the discussion of parameter. So we are gonna discuss some parts. लिखो heading लिखो barometer. Just write the heading barometer, and then write it is a device to measure the atmospheric pressure. It is a device to measure atmospheric pressure. Full stop. Atmospheric pressure is the pressure created by the atmosphere atmospheric pressure is the pressure created by the atmosphere due to the gravitational pull on the atmosphere. Full stop. Barometer measures atmospheric pressure indirectly. Barometer measures atmospheric pressure indirectly. Full stop. Full stop, no, sorry, comma. That is, you can use I full stop, E full stop, no problem. That is, comma. It actually measures the pressure created under a liquid column. The pressure created under a liquid column where atmospheric pressure equals to liquid pressure. Where atmospheric pressure equals to liquid pressure. Full stop. नीचे पैराग्राफ लिखो. The empty space above the liquid inside the test tube the empty space above the liquid inside the test tube is a vacuum. Full stop. Or it can contain very low pressure mercury vapor. Very low pressure mercury vapor due to evaporation. Due to evaporation. Bracket. Assuming the liquid used in the barometer discussed is mercury. Assuming the liquid used assuming the liquid used in the barometer is mercury. Full stop. This very low pressure is considered negligible slash zero. This very low pressure is considered negligible slash zero. Next paragraph লিখো, when a mercury filled test tube when a mercury filled test tube আচ্ছা ফিগারে আরেকটা লেবেলিং করা লাগবে, আরেকটা লেবেলিং আমি করতে ভুলে গেছি, সেই লেবেলিংটা আমি করতেছি। তোমরা এই হরাইজন্টাল লাইনটাকে অ্যাজিউম করো, হ্যাভ এ লুক অ্যাট দিস হরাইজন্টাল লেভেল and draw arrows to an assumed line up to that. Do not draw it below that assumed line. Do not draw it too high. And we're going to label this one as mercury pressure. I can actually give a dot 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 line over here to show you that line. I think that would be better. Figure একটু এই এডিটটা করো. I added one new edit labeling here. Give a dot 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 line to continue this outside mercury surface inside the test tube, and draw vertically downward arrows and label those arrows as mercury pressure. Mercury pressure. আচ্ছা লাস্টে কি লিখছিলা একটু কেউ একটু বলো তো, আমি ভুলে গেছি। Someone?
Mercury filled test tube.
Mercury filled test tube.
আচ্ছা, when a mercury filled test tube is put upside down inside the mercury bath, when a mercury filled test tube is put upside down inside the mercury bath, and is opened comma mercury inside the test tube starts flowing out into the bath. Mercury inside the test tube starts flowing out mercury in the test tube starts flowing out in the mercury bath. full stop. This keeps happening this keeps happening till the pressure of mercury column becomes equal to atmospheric pressure. Full stop. At this equilibrium condition, at this equilibrium condition, the difference of height the difference of height difference of height কাটো sorry the difference of vertical height লাগো the difference at this equilibrium point the difference of vertical height vertical ওয়ার্ডটাকে গোল্লা করে তার আশেপাশে অনেক কয়েকটা স্টার মার্ক দাও এই ভার্টিক্যাল ওয়ার্ডটা খুব ইম্পর্টেন্ট at this equilibrium point the vertical height between the mercury levels inside and outside the test tube inside and outside the test tube works as H for the formula P equals to H rho G. Works as H for the formula P equals to H rho G. Works as H for the formula P equals to H rho G. P equals to H rho G তে capitalization properly maintain করবা দেখো P টা হচ্ছে capital H টা small letter rho টা হচ্ছে এখানে G টা হচ্ছে এখানে you should preferably maintain these alignments P equals to H rho G. আচ্ছা বলবান একটা ছোট জিনিস একটু করো তো ফিগারে এইচটাকে আমরা লিখি আমি এখানে দেখো এখানে 76 সেমি লিখছিলাম শুধু দেখতেছো এই যে এখানে 76 সেমি আছে না যদি জায়গা থাকে তাহলে ওটার পাশে লিখো আমার জায়গা ছিল না দেখে মুসলাম এখানে লিখো হচ্ছে H equals to 76 সেন্টিমিটার তাহলে এটা বুঝতে সুবিধা হবে যে এই 76 সেন্টিমিটার অ্যাকচুয়ালি কি জিনিস H equals to 76 সেন্টিমিটার লেখো তাহলে পরে এটা বুঝতে সুবিধা হবে যদি তোমার বামে স্পেস থাকে জাস্ট H equals to টা আটায় দাও আর না থাকলে একটু মুছে লিখো লিখছো
Yes, sir.
আচ্ছা At this point, the difference in the vertical heights of the two mercury level inside the test tube and outside the test tube works as the H for the formula P equals to H rho G. Full stop. For standard atmospheric pressure, the H is measured to be 76 centimeter. For the standard atmospheric pressure, the H is measured to be 76 centimeter. Full stop. So atmospheric pressure can be also expressed like this. এই পুরো লাইনটা লেখো, P atmosphere equals to 10 to the power 5 Pascal equals to 1 bar equals to 76 centimeter Hg equals to 760 millimeter Hg. আচ্ছা, এই পর্যন্ত বুঝা গেছে কিনা সবার? Any questions so far?
No, sir.
আচ্ছা, apparently there is no response, so I hope এটা বুঝা গেছে। এর নিচে প্যারাগ্রাফে লিখো, using a stand clamp support system, using a stand clamp support system, the test tube is held in place. The test tube is held in place. Full stop. So the levels shown as A and D the levels shown as A and D never depends upon change of atmospheric pressure. Never depends upon change of atmospheric pressure. Full stop. Only the two mercury levels, comma, B and D, only the two mercury levels, comma, B and D are affected by change of atmospheric pressure. Full stop. নিচে প্যারাগ্রাফে লিখো, when atmospheric pressure increases, when atmospheric pressure increases, comma, the open surface of mercury bath The open surface of mercury bath the open surface of mercury bath is pushed down more strongly is pushed down more strongly. আমি যে কিছু খাচ্ছি এটা কি বোঝা যাচ্ছে? Okay, don't write that. The open surface of the mercury bath is pushed down more strongly, and some mercury from the bath enters in the test tube. Enters into the test tube. Some mercury from the bath enters into the test tube. Full stop. This increases H. Subsequently, calculated pressure P equals to H rho G also increases. Subsequently, calculated pressure P equals to H rho G also increases. Full stop. In this case, level B goes up and level C goes down. Level B goes up and level C goes down. Full stop. এরপরে একটা স্কোয়ার ব্র্যাকেট ওপেন করো, একই প্যারাগ্রাফে একটা স্কোয়ার ব্র্যাকেট মানে হচ্ছে থার্ড ব্র্যাকেট, দিস ওয়ান। একটা স্কোয়ার ব্র্যাকেট ওপেন করে ভিতরে লিখো, because of the difference of cross sectional area because of the difference in cross sectional area because of the difference in cross sectional area, comma, level C goes down by a very small amount goes down or lowers, কোনটা লিখলে ভালো হয়? It makes sense, right? Goes down তো বুঝতেছো, মানে what do I mean by this?
Yes, sir.
Level C goes down by a very small amount compared to the rise of level B. What? Sorry, that wasn't meant to happen. একটু পড়ে শোনাও তো, স্কোয়ার ব্র্যাকেটের ভিতরে কি লিখছো? বিকজ অফ দ্য someone because of the difference, একটু পড়ে শোনাও, I got
Because
distracted.
of the difference of cross-sectional area, level C goes down by a very small amount compared to the rise of B.
Compared to the rise of B. Direct close. Direct close এর পরে ফুল স্টপ দিবা, তুমি এরপরে বড় হাতে লিখবা এই জিনিসটা, অ্যান্ড ভাইস ভার্সা। তোমরা আমাকে বলো এই ভাইস ভার্সা মানে কি, মানে এই কেসে ভাইস ভার্সাটা কি মিন করতেছে?
The reverse operation.
রিভার্স অপারেশন। সো এই রিভার্স অপারেশনটা হইলে, if you try to derive the whole reverse operation and then try to have a read from the given paragraph, how would this sound like? Let me pick someone to ask for this information. uh, Ishaq Zahin. So Ishaq Zahin, hello. Ishaq Zahin. Ishaq Zahin, can you use the microphone a bit? Is it possible? Can you speak to the microphone a little bit? Okay, Ishaq seems to have some technical difficulties with his microphone. So, Ishaq, we'll skip you for this time, but next time, please try to answer the question. I really appreciate this. Zarin, do you have a functional microphone? Zarin Tasnim.
Yes, sir.
Attempt to read the paragraph for the vice versa version. And everyone, have a look at your own paragraph and try to listen to what Zarin is saying and try to figure out at which points she is possibly making a mistake. Zarin, try to do this as slowly as you need to and start. For the vice versa situation, what should happen? বলো, ট্রাই করো, ভুল হলে কোনো সমস্যা নাই, I'll help.
Sir, can I not attempt, please?
I'm sorry.
Can I not attempt?
So Zarin seem to have cough. Acha, can we have some volunteer to do this? Anyone interested to attempt their understanding on their own? Anyone? Asif Irfan, can you attempt this, please?
So as the atmospheric pressure decreases, H will also decrease, uh, and this would cause the pressure hg to also decrease. Uh, because of the difference of the cross-sectional area, level C would upper its level by a very small amount compared to the downfall of D, something like that.
Precisely that. What Asif said is absolutely correct. Did everyone get this? সবাই কি বুঝছো কি বলছে? Yes or no? If you don't want to use the microphone, just uh, write in the chat window that yeah,
Yes,
we got
sir.
it. That works. So this is the scenario. Now, this is the most common type of questions that we have. And one more important thing that I asked you to give a circle and a cross mark about is that for this kind of figures, h represents the vertical height. Now, how does that help us, or how is that important? Let me, can I, no, I cannot actually, this is not going to work. So let me just try to draw a pretty crude version of a barometer, and let me explain what I'm trying to mean here. Let's say we have a barometer where the mercury bath is really large. Let's say we have this much big mercury bath, where we have mercury up to this level. Let's say we have a mercury up to this level. If we have placed a vertical cylinder, vertical test tube, which is definitely longer than 76 centimeter, uh, let's say this is the long test tube, and let's say this is the 76 centimeter mark. And if we keep it vertical, this entire thing will be filled up with mercury. Now, if we have a cylinder that is, if we have a test tube that is slightly tilted, let's say if we have a test tube that looks like this, maybe even longer, that was also initially completely filled with mercury. This test tube will also hold mercury up to this level, so that the vertical height of this mercury level from the open surface mercury level would still be 76 centimeter. You can have any other shape. You can have a carved tube, let's say a tube that looks like this, and then it comes down like that. You can have a carved tube like that looks like a bit of like the small intestine. In that case also, you're going to have the mercury level up to this level. This curvature would not matter. What would only matter is the vertical height. This is only applicable as long as we are using the same liquid. So which means that this whole thing is mercury, this is also mercury, this is mercury, this is also mercury. Last information, if we place a test tube that has a smaller height than 76 centimeters, let's say if we have a test tube that is, for example, let's say if we take this test tube and start to tilt this to the right. Let me try to select this. Can I select this only? No, I cannot. So yeah, okay, wrong attempt. So let's say if we start to tilt this test tube and eventually make the tip go below the 76 centimeter level, let's say this is 76 centimeter level. Let's say if we place the test tube in this manner, let's say we have tilted it so much that the tip has gone below the 76 centimeter level. This was our 76 centimeter level. This will get entirely filled up with mercury, and this will become entirely filled up with mercury whenever it was maybe at this level. At this level, it would start getting completely filled up with mercury. So that's the important bit, which means that if we have 76 centimeter vertical space within the test tube, 70 centimeter of vertical space within the test tube, then we can have some sort of vacuum, 0 pascal. But if there is no such height available, then there wouldn't be any vacuum. It would be completely filled with mercury. This is one of the aspects. The other aspect, which I'm not going to make you write, but I'm going to tell you, is that why so much obsession about mercury? I mean, what's the big deal? I mean, why mercury? Why not any other liquid? The entire reason for using a mercury within a barometer is because of the advantages that we can have. Try to understand. Pressure equals to H rho G. Atmospheric pressure has a typical value of about 10 to the power 5, and H is the value that we don't know. Mercury has a density of about 13,596, and G has a pretty good value of 9.81. This is the actual true value. For your syllabus, you use 10, but you can use 10. If you use all of this value, ultimately we're going to get the H equals to 0.76 centimeter, which we have seen in our last class for the calculation. Now, even if I don't use these numbers, let me just try to give you a bit of an idea how the rho actually helps us. If I subject the H from this equation, have a look. H equals to কি আসবে? Pressure divided by rho into G. If you try to understand, pressure of the atmosphere is a constant. G of the atmosphere is also G of the Earth at a specific point on the Earth's surface is also a constant. So H would be practically dependent upon this density. And because they are in this one is in the diameter side, so I can write over here that for considering pressure, atmospheric pressure, and gravitational acceleration as constants, we can write that height of the mercury column within a barometer is inversely proportional to the liquid's density, which means if we use a dense liquid, we're going to have a small height. If we use a less dense liquid, we're going to have a larger height. Using mercury, which is actually quite dense and is a liquid, it's a liquid metal at room temperature, the height is becoming to be 7 centimeters. If you wonder why couldn't we use water for this purpose, the answer is yes, why not? We could use water. Let's try to do this whole calculation for water. Let's say atmospheric pressure is 10 to the power 5. We are trying to calculate the height. The density of water is about 1000 kg per meter cube at 4 degrees Celsius, which is the standard value that we use. And for the sake of understanding, we use 9.81, or you can use also 10 over here. But Okay, let's use 10 over here, an approximated value which is applicable in our syllabus. So if you do this one, we have 4 zeros over here, and we have 5 zeros over here. So in this case, h will become precisely 10 meter. But if you take it as 9.81, it will be somewhat bigger than 10 meters. So I'm going to give you a bit of an approximation mark over here because of the rounding off factor. It means if in place of if we make the parameter using a mercury, the height for the mercury column is going to be 0.76 meter, which means this is somewhat smaller than a meter. For those of you who have a bit of an idea about meter, for those who have seen a meter scale in your school lab or someplace else, you know how big a meter is. For those of you who haven't seen a meter rule, what I'd ask you that take one of your large rulers. Typically, these rulers are 30 centimeter long, and try to place about three and one third. So three of them side by side on a table. Maybe let's just flip it. I mean, place the ruler on the top, then flip it with one edge, and then flip it one second on the other edge. So that way you get three times the length, and then consider about 10 centimeter within the ruler's length for the next part. That much is practically somewhat equivalent to 100 centimeter or 1 meter. So you get a bit of an idea that how big is 1 meter. So 0.76 centimeter means that this is a setup that can be operated within a laboratory environment, within a laboratory room. But if you made this same parameter using water, the height of this vertical column would be 10 meter. Now, 10 meter is a pretty difficult length to work with. The typical height for a room for a standard house that we live in Dhaka, the typical height for a standard room is about 3 feet or sometimes 2.5 feet. Because in Bangladesh we don't have sorry 3 meters, my bad. The typical height of a room is about 3 meters or sometimes 2.5 meters if we are considering the false ceiling, or for a more efficient air conditioning system sometimes the heights are also kept at 2.5 meters. Why am I telling you this? The reason I'm telling you this is that if we do make a barometer using water, it would be impossible to operate that thing within a single laboratory room. We would have to set it outside, and that thing would be as tall as at least, let's say, uh, 3.5 story tall for the water column itself. And using that for our calculation would be a very bothersome process because it will be also outside. We have to maintain this. We have to safe keep it. We should take care that it doesn't fall off for the wind and everything. So clumsy process. So that's the whole point, that why we are so much obsessed with mercury, because mercury has such a large density. It can produce a very high pressure at a smaller depth of itself, or under a certain small height. It can produce a pretty significantly strong amount of pressure. So the H can be pretty much manageable and small. That's why we are so much that's why we are preferring to use mercury over water. But if you ask me that, well, what if we use water? Should we not call it a barometer? Of course, we can use any liquid. That's why for the first description of the barometer, up to a certain point, I have continuously used the term liquid. Then whenever I was started to talking about the evaporation thing, the possible evaporation thing under low pressure for the vacuum space, then I use the term mercury because then I had to be a bit more specific for the liquid's name. So that's the reason why we prefer mercury. If you can use any other liquid, you can use glycerin, you can use oil, you can use petroleum, we can use saltwater solution, we can use any liquid that you can think of. Sorry, but how much height of that liquid column is we're going to handle is going to be inversely proportional of the density. The less dense that liquid is, the taller that tower has to be. So that's why we prefer mercury. বুঝা গেছে কিনা বলবান?
Yes, sir.
আচ্ছা, এই যে ফিগারটা এখানে আঁকছি, রাফলি এই ফিগারটা এঁকে নাও। Draw these 4 or 5 position of these things, and approximately keep a horizontal line to represent 76 centimeter, and fill these up all with hash marks. And this one should be also filled up with hash mark completely all the way, and this one will also fill up with hash mark completely on the way. এটা একটু এঁকে নাও। ফিগারটা আঁকো, তারপর আমি নিচে বলতেছি কি লিখতে হবে। ওকে, আঁকা হয়েছে? This figure doesn't have to be beautiful, you just can roughly shape it. ফিগারটা নিচে লিখো vertical height, star mark star mark star mark, vertical height স্টার মার্ক স্টার মার্ক স্টার মার্ক, এই দুটো ওয়ার্ড লিখলেই হবে। যখন তুমি ফিগারটা দেখবা সাথে সাথে বুঝে যাবা যে এখানে অ্যাকচুয়ালি কোন জিনিসটাকে এমফাসাইজ করা হয়েছে। ইউ উইল রিমেম্বার দিস। ডান?
Done, sir.
আচ্ছা, at this point I'm going to help you for many of these MCQs over here. There are some quite interesting MCQs if you ask me, but how about, since we just finished the idea for the barometer, how about we try these MCQs? There are only 4 MCQs over here, 5 MCQs over here actually. I think one of them, no, none of them are copy over here, only 5 MCQs. So let's give this a try and see if you can solve them. এই 8.2টা সবাই ট্রাই করো, এখন 5টা একসাথে ট্রাই করো, যা যা পারতেছো না স্কিপ করে পরেরগুলো ট্রাই করো। I'll give you some time, I'll give you let's say 7-8 minutes to try these 5 MCQs, then we're gonna discuss these parts. Jump in. The diagram shows a simple marker parameter. Which one of the following does not cause the height of the marker column to vary? চেঞ্জিং ফর্মুলা হচ্ছে কি, আমাদের এইচ এর ফর্মুলা হচ্ছে h equals to p divided by rho g. এই তিনটা ভ্যারিয়েবলের চেঞ্জের জন্য the change of any of these 3 variables or simultaneous change of any of those variables will affect the value of h. Anything other than these 3 will not affect the value of h. You can also have a thicker tube over here. I actually forgot to draw a thicker tube. If you even had a thicker tube, you'd still have it the level at 70 centimeter because cross-sectional area of the marquee column is not a part of this equation, which means cross-sectional area simply doesn't matter. So এখানে বলছে হচ্ছে changes which one will not cause the height of mercury vapor. Changes in the atmospheric pressure will cause. Changes in the value of G will cause change. Evaporation of mercury from the barometer reservoir. Now try to understand what does this mean. If we have some mercury that is evaporated from this surface out, এখান থেকে যদি আমাদের কিছু evaporation হয়, not from the inside, simply কি হবে, আমাদের এই সারফেসের লেভেল কিছু নেমে যাবে এবং ওই অ্যাটমসফিয়ার প্রেসারকে ম্যানেজ করার জন্য এই সারফেসের লেভেলও কিছু নেমে যাবে। আলটিমেটলি আমাদের এই এইচটা সেম থাকবে। Leakage of air into the tube will cause the change to happen, because if we have some leakage of air in the tube somehow, let's say because of mishandling or by some mechanism, obviously এখান থেকে যদি somehow কিছু এয়ার এখানে ঢুকে যায় তাহলে এই পয়েন্টটাতে আমাদের প্রেসার আর ইফেক্টিভলি জিরো থাকলো না। The pressure inside this location will not be zero anymore, which means the pressure over here would be something else than zero, something bigger than zero obviously. So the height of the mercury column would be lower than what it is supposed to be. So D also affects the height, C does not affect, B affects, A also affects. So C is the correct response for this answer. বুঝতে পারছি?
Yes, sir.
So number 5 টা দেখবো। Number 5 is a figure which is not drawn to scale, just to bother with your head. This figure is not drawn to scale. Let's have a look. কোশ্চেনে বলছে the height of a mercury parameter is h when the atmospheric pressure is 100,000 pascal. What is the pressure at x? X পয়েন্টের প্রেসার কত হবে? হ্যাঁ, একটা জিনিস দেখো, you have to understand this thing. এই পয়েন্টের প্রেসার হচ্ছে 0. The farther you go down, the pressure drops. Sorry, the pressure increases. Exactly at this level, এই প্রেসারটা হচ্ছে কত? Perfectly 100,000 pascal. 100,000 একটা বেশি দিয়ে ফেলছি। 100,000 pascal. And কোশ্চেন হচ্ছে এই এক্স পয়েন্টে আমাদের প্রেসার কত হবে? You have to understand, এই যে ফর্মুলা P equals to H2O যে ছিল, এখানে H টা কিন্তু রিপ্রেজেন্ট করতে হচ্ছে ডেপথ অফ দ্য লিকুইড from the surface. So in this case you have to understand that how much surface is remaining over here. এইটুক মার্কারি কলামের নিচে কতটুকু প্রেসার থাকবে? So that if this is H by 5, this one is supposed to be 4H by 5, ঠিক না? The remaining part, basic subtraction, which means at this point we're gonna have 4/5 of the pressure of the whole. So জিনিসটা হচ্ছে এরকম যে পুরো হাইটের নিচে আমাদের প্রেসার হচ্ছে 100,000 pascal, 4/5 of the height নিচে প্রেসার হবে হচ্ছে 4/5 of 100,000 pascal. The farther will go up, pressure will reduce, and at this point the pressure will become 0. The farther you go down, pressure will increase, and ultimately at this point the pressure will become 100,000 pascal. If you go even down, the pressure will be even more. more than 100,000 Pascal, which is more than the atmospheric pressure because atmospheric pressure is working in this surface. So in this case, the answer would be 4/5 into 100,000. এটা হচ্ছে বেসিক আন্ডারস্ট্যান্ডিং, এখান থেকে হিসাব করলে যা হয়। এটা ছাড়াও আরেকটা আন্ডারস্ট্যান্ডিং হচ্ছে পি ইকুয়ালস টু এইচ রো জি। এই ইকুয়েশনে আমরা প্রেশারকে রিলেট করতে যাচ্ছি হাইটের সাথে, which means we can consider the rho as a constant, which is obviously this is the same material, and g as a constant as well, which basically tells us that pressure and height are directly proportional. More height represents more pressure and vice versa. Which, if you understand this equation, then you can also write this thing: P1 by P2 equals to H1 by H2. প্রপোর্শনালিটিকে আমরা ইকুয়েশনে কনভার্ট করলে আমরা এরকম একটা জিনিস পাই, যেটা তোমরা আগেও দেখছো। সো এখানে আমি যদি প্রথম কেসে প্রেশার লিখি, লেটস সে দ্য গিভেন প্রেশার ইজ 100,000 ফর অ্যাটমসফিয়ারিক প্রেশার divided by the unknown pressure that we want to calculate. The height এই 100,000 প্যাসকেলের জন্য আমাদের রিলেভেন্ট হাইট হচ্ছে h পুরাটা, আর h2টা হবে হচ্ছে 4h by 5। এই রিপ্লেসমেন্ট গুলো বোঝা যাচ্ছে কিনা দেখো, হ্যাভ এ লুক। এই প্রেশারের জন্য এই হাইট, এই প্রেশারের জন্য এই হাইট, এই প্রেশারটা কত সেটা আমাদের আননোন। তাহলে এখান থেকে আমরা এখন আস্তে ধীরে সাইড চেঞ্জ করে ক্রস মাল্টিপ্লাই করলে এইচ আর এইচ কাটা চলে যাবে, আলটিমেটলি তুমি ক্যালকুলেট করলে ওই 80,000 প্যাসকেলই পাবা। বুঝছো কি?
Yes, sir.
ইশাক বুঝা গেছে? আচ্ছা, আমরা ম্যানোমিটার ডিসকাশনটা একটু দেখি। আমার ম্যানোমিটার ইজ দ্য লাস্ট থিং in our density pressure chapter. So let's have a look at the manometer thingy, and then we'll can see some MCQ for solving. Manometer is a very simple device, but it can be designed to be pretty confusing. Manometer description আমরা খেয়াল করি, তোমরা তোমাদের নোটস থেকে পড়ো, আমি আমার পিডিএফ থেকে পড়তেছি। Manometer: this device is used to measure pressure difference of two sources. A manometer is necessarily a U-shaped tube that is half filled with a dense liquid. One of the sides is always open, thus the liquid surface always experiences atmospheric pressure. The other side is attached to a source for which we want to measure the pressure. So যেটা মেজার প্রেশার করতে চাইবো সেটা এক পাশে লাগানো থাকবে, আর অন্য পাশটা সবসময় অ্যাটমসফিয়ারের সাথে ওপেন থাকবে। ওপেন সারফেসের প্রেশার সবসময় হচ্ছে অ্যাটমসফিয়ারিক প্রেশার, irrespective of level, it is always atmospheric pressure. Because the pressure difference of the, for example, a pump, a vacuum pump, boiler, pressure cooker, etc. Because of the pressure difference on the liquid of the two sides, because of the pressure difference on the liquid on two sides, one side goes down and the other side goes up until the pressure is balanced. এই লাইনটা হচ্ছে কি লাইন বা বুঝার মতো লাইন। এটা মানে হচ্ছে, আমি এখানে জিনিসটা দেখাই তোমাদেরকে। আচ্ছা আমি শেষ করি, পড়াটা শেষ করি, তারপর লিখে বলছি। When the liquid levels become stable, we can take measurements of the liquid levels to find delta H. Delta P equals to delta H rho G. Gives the pressure difference. High pressure side goes down and low pressure side goes up. এটা মনে করা হচ্ছে আমাদের একটা সার্টেন ম্যানোমিটার। ম্যানোমিটার ইজ বেসিক্যালি ইউ শেপ টিউব। লেটস সে এখানে আমরা সোর্সটা লাগাবো, এই কেসে এখনো পর্যন্ত কোনো সোর্স লাগানো নাই। লেটস সে ফর বোথ অফ দ্য সারফেসেস আর ওপেন টু অ্যাটমসফিয়ার, বিকজ দে আর বোথ open to the atmosphere, the two liquid levels are exactly at the same level. So the delta H is 0, basically means pressure on side A equals to pressure on side B, or delta P equals to 0. Source pressure and atmospheric pressure are equal. It is a typical case if we don't connect anything over here. Let's say we have connected the manometer to a source, and then we achieve this situation that the liquid on the source side or B side liquid has gone down and A side liquid has gone up. This basically means the pressure on this side is stronger compared to the pressure on this side. এই পাশের প্রেসার চাপ দিয়ে লিকুইডটাকে ঠেলে নামায় ফেলছে, আর যেটা সেজন্য লিকুইডটা এই পাশে উঠে গেছে। অ্যাজ এ রেজাল্ট আমাদের এই দুটো লিকুইড লেভেলের মধ্যে একটা প্রেসার ডিফারেন্স ক্রিয়েট হয়েছে। So we have some pressure difference because of the mismatching heights. So if I take this image out, can I take this image out? I cannot. Let me just do a screenshot. All right. So if we have a look at this case, you can see that This is the part that I want you to understand. The open surface pressure, let me draw with red. The surface at this liquid level, irrespective of its position, this liquid level pressure is always the atmospheric pressure, because this is the side that is open to atmosphere. So we basically know what is the pressure of this level. This is 10 to the power 5 Pascal. Same here, same here. Whenever for this source, for this second figure source, you can see that this liquid level has gone down, which means the pressure of B should be definitely bigger than the pressure of A. That's why it could push the liquid down, and the liquid had to went up on the other side till a certain point. Till a certain point. What is that point? It will happen such that whenever this side is going up, this level will experience a higher pressure. Have a look how that higher pressure is created. If I draw a line, dotted line, through that goes to both the tubes for the level of the lower side, you have to understand that within this same horizontal level, the pressure is exactly same. So whatever the pressure that is working over here is exactly equal to the pressure that is working over here, which means এখন কথা হচ্ছে যে এই পয়েন্টের প্রেসার কত হবে, এই পয়েন্টের এই সারফেসে অলরেডি অ্যাটমসফিয়ার প্রেসার কাজ করতেছে, অ্যাটমসফিয়ার প্রেসার অলরেডি ওয়ার্কিং হিয়ার, additional to the atmospheric pressure we have this much liquid pressure at this depth. We have this much liquid pressure at this depth, which means delta P equals to delta H rho g, and PB is bigger than PA. So এটা হচ্ছে আমাদের প্রেসার P equals to H rho g এর basic manipulation. What I was doing that P equals to H rho g, H rho g. So if I want to define the pressure difference, we are causing that H to become delta, difference in height, into rho g. So that's the basic equation, because the rho is basically same for both the sides. We are using a single liquid, and g is also a location based constant, so we can consider that as a constant as well. So for this scenario, high pressure minus low pressure equals to the pressure difference. And যেহেতু আমরা এটা অলরেডি জানি, অ্যাটমসফিয়ার প্রেসারটা অলরেডি জানি, অর এ সাইডের প্রেসারটা অলরেডি জানি, ডেল্টা এসটা আমরা মিটার রুল দিয়ে মেজার করতে পারবো। ডেন্সিটি আমাদের আগে থেকে জানা থাকবে, ডিপেন্ডিং আপন হোয়াট লিকুইড ইউ ইউজ। ইফ ইউ ইউজ mercury, we will know that value. If you use water, we will know that value. If you use some other liquid, we will know the value of this thing from earlier. And g is also a constant, so you can see that we know this, all of these values, which means b can be now calculated. That's basically the aim. But what you really need to understand, manometer doesn't give you the value of the source pressure directly. It only gives you the difference of those two levels. And subsequently, the manometer gives you this thing. Manometer gives you the pressure difference of the two sides. Because we know the pressure of one of the sides, the other side's pressure can be calculated out. আমরা যদি এই পয়েন্টের প্রেসারটা না জানতাম, তাহলে এই কোশ্চেনটা কিন্তু সলভ করা যেত না, কারণ সেই কেসে আমাদের এটাও আননোন থাকতো, এটাও আননোন থাকতো। We wouldn't be able to calculate any of their values. Because we already know the value of this thing could be calculated out. এই পর্যন্ত বুঝা গেছে কিনা? আমি অনেকগুলো কথা বললাম, এখানে মনে রাখার জন্য সহজ বুদ্ধিটা হচ্ছে এরকম, you always can remember that the level of the manometer, left or right doesn't matter, which is lower, the lower level always represents the high pressure side. The high pressure pushes the liquid down, and that causes the liquid level to go up on the other side. The lower level liquid level is always the high pressure side, and vice versa. If we connect this manometer to a different source, let's say this source over here is a vacuum pipe or is a vacuum cleaner, so you have connected the manometer on the opening of the vacuum cleaner. So in this case, it is actually producing a bit of a suction, which means the pressure is lower than the atmospheric pressure. For that scenario, atmospheric pressure would be the bigger value, and the source pressure would be the lower value. So this is the lower level, so this is the high pressure side, this is the higher level, this is the low pressure side. This side is pushing down, so the liquid goes up, and the difference of these two levels is delta H. So delta P equals delta H rho g. In this case, atmospheric pressure or PA is bigger than PB, so PA minus PB equals to delta H rho g. So this is how I prefer to teach. It works as long as you can detect which side has the higher pressure and which side has the lower pressure. You would have no difficulty doing this math. You always subtract the high pressure from the low pressure to get the pressure difference. So in this case, A was the high pressure side, so high pressure minus low pressure equals to delta H rho g. And for this figure, B was the high pressure side, so PB minus PA gives you the pressure difference. So applicable cases আমাদেরকে অবজার্ভ করতে হবে যে কোন পাশের লিকুইড লেভেলটা লোয়ার। দ্য লোয়ার লেভেল ইজ অলওয়েজ দ্য হাই প্রেশার সাইড। এটা বুঝা গেছে কিনা বলবান?
Yes, sir.
আচ্ছা, কার কোনো কোশ্চেন থাকলে বলো। I'll get back to the notes and I take your attention to this part. Have a look at this thing. এই যে এখানে যে কথাটা লেখা ছিল, because of the pressure difference on the liquid in two sides, one side goes down and the other side goes up until the pressure is balanced. When the liquid levels become stable, we can take measurement of the liquid levels to find delta H. Delta P equals delta H rho G, and then the whole thing follows through. আচ্ছা, এখানে একটা জিনিস খেয়াল করি, rho is inversely proportional to delta H. So for manometer we use very dense liquid such that delta H is small for pressure difference. This increases the useful range of manometer. এটা মানে হচ্ছে আগের মতোই, যদি আমাদের রোটা অনেক যদি আমাদের লিকুইডটা অনেক লেস ডেন্স হয়, তাহলে অল্প প্রেসার ডিফারেন্সের জন্য হাইট ডিফারেন্স অনেক বড় হয়ে যাবে, হুইচ মিন্স তোমাকে অনেক লম্বা একটা ইউ টিউব ইউজ করতে হবে, মানে ইউ শেপ টিউব. But if the liquid is actually quite dense, then the length of or height of that U-shaped tube can be pretty small and can be easily handleable and replaced and located in places for different type of calculation. So so if we are trying to achieve a long range, we should use a dense liquid, whereas if we are trying to measure a very small variation of change of pressure, a very small variation or very precise variation of pressure, in that cases a less dense liquid can be appreciated. Now for those who don't understand this thing, let me show you what I mean. Let's say there is a certain device where you want to measure a very small variation of pressure, which means that the source pressure, let's say this is the source pressure and this is the atmospheric pressure, this is the source over here. Let's say you know that this source is always producing a slightly bigger pressure than the atmospheric pressure. So let's say this level is down and this level is up. But if this source produces a bit of a variation of pressure, you would like to measure that, you would like to see that, which means even a small delta P should produce a visible delta H. So your delta H should be significantly large, preferably, even for a small delta P. How can we achieve this thing? Have a look. If we subject delta H from this equation, I can write that this would be given by delta P divided by rho G, which means, have a look. Delta P is the small pressure change for which we want to have a large height variation. It can be only achieved if the density on the denominator side is also very small, because you need to understand that whenever we divide some number with a small number, the number gets bigger. Very basic idea. If you divide 10 by 2, you get what? 5. But if you divide 10 by 4, you get 2.5. So if the denominator is small, the ultimate result is large. So if you want to get a bigger delta H value, preferably rho should be smaller, which means if we want to, for some apparatus, for certain required cases, if we want to measure a very small variation of pressure or a very minor change of pressure effectively, in those cases a less dense liquid for the manometer is recommended. But if we want to measure a very large range of change of pressure, let's say a certain device will be turned on and off, it is going to work as a vacuum cleaner, also going to work as a pump in alternate cases. So if you want to have a large range of change of pressure, in that case, a very dense liquid is preferred so that the liquid level does not go up and down too much, so that the device doesn't have to be made very large. So both of the, we have both the uses for dense liquid and less dense liquid, depending upon what purpose are we trying to serve, what value are we trying to get out of our experiment. এই জিনিসটা বুঝা গেছে? এটা নিয়ে আমি স্টুডেন্টদের আরেকটা জিনিস বলি, সেটা হচ্ছে ওয়ান থিং দ্যাট অ্যাকচুয়ালি কুড মেক সেন্স টু সাম অফ ইউ, ইট ইজ দ্যাট if you have a sharp knife, you can cut slices of a fruit or vegetable very thinly. With a sharp knife or with a blade or with a scalpel, you can cut really thin slices. But if your cutting device, blade or knife is blunt, you cannot make sharp slices. This is something like that, that the smaller the density, the large would be the variation. So you can, even minute changes can be observed. I'm not sure if the idea resonates with your understanding, but for some people it works, for me it works. বুঝা গেছে কি বলছি বলবান? এই কনসেপ্টটা ক্লিয়ার হয়েছে কিনা দেখো। কার কোনো কনফিউশন? No, apparently. So if you try some MCQs from the for the manometer part, we have a quite a good number of repetition over here. So we can actually give it a go for these things. We have a little bit of time left. How about you just give it a try? 8.3. Copy question হচ্ছে 5 and 6 both are identical questions. 1 and 3 are identical questions. So practically we have 5 questions over here. Out of 7, there are 5 unique questions. Try করো এই কোশ্চেনটা ট্রাই করো, এই পার্টটুকু ট্রাই করো, না পারলে আমি হেল্প করতেছি। Everyone go ahead. Above atmospheric pressure means more than atmospheric pressure. Below means less. This is a pretty interesting question that students sometimes mess up. What you have to understand that the reason they have given 2 9 centimeters, what they're trying to represent that when we did not connect this source with this manometer, both of these liquid levels were at this level. The moment we connected this from the gas cylinder, this one level went down by 9 centimeters, this one went up by 9 centimeters. So what is the delta H for this question? Is it 9 centimeter or is it 18 centimeter? Remember, delta H is the height difference between the two levels. So what is the delta H for that question? 9 or 18?
9.
No.
18.
Let me show you side by side. Maybe that will help. Maybe that will help. Here, one of the level went down by 9 centimeter and the other level went up by 9 centimeter. So what I want you to judge, what is the delta H? Delta H is the height difference between the two levels. So what is the delta H here? Not 9, 18 centimeter. ঠিক কিনা? এটা বুঝাটাই হচ্ছে এই এমসিকিউ এর চ্যালেঞ্জ। If you understand this part, rest of the part is pretty simple. If you understand that this height difference is represented by 18 centimeter of liquid pressure, then you can very easily choose it is 18 centimeter of liquid above atmospheric pressure because it is more than the atmospheric pressure. দেখো বুঝতে পারছি কিনা? নুরান বুঝছো?
জি স্যার।
Okay. এটাও সিম্পল, এটা রিপিট, এটা ইজিলি করতে পারবা। You just have to subtract these two and find out the delta H. এটাও করতে পারবা। This is 8 centimeter above. This 4 centimeter doesn't matter because delta H is the height difference between the two sides. That's it. Whatever you have below, how much they have moved individually, none of this matters. What matters is what is the total height difference between the two liquid levels. That's it. আর তো কিছু দেখি না, বাকিগুলো মোটামুটি সবই সেম। আচ্ছা, আজকে আমি এতটুকু পর্যন্ত রাখতেছি। আই জাস্ট হ্যাভ টু স্টার্ট অ্যানাদার ক্লাস, ও লেভেলসের ক্লাস। সো তোমরা এই এমসিকিউ গুলো ট্রাই করো। নেক্সট ক্লাসে হচ্ছে তোমরা এই এমসিকিউ গুলো ট্রাই করবা, এই পেজ এমসিকিউ গুলো ট্রাই করবা। আর যদি শেষ করে ফেলতে পারো অ্যাটেম্প করে, তাহলে পেপার 2টা একটু অ্যাটেম্প করবা। পেপার 2টা আমি কম্পালসারি হোমওয়ার্ক দিচ্ছি না, বাট এই ওয়ার্কশিটের পুরো এই এমসিকিউ পেপারটা compulsory homework দিচ্ছি। We'll pick up problems from this question, from this worksheet in the next class, and we'll also start the paper 2 worksheet discussion, and then we'll go ahead from that point. আজকে এটুক থাক। Thank you very much.